Good day, Bayaw. So today, we have here another problem that we are going to find its solution from the book of Fluid Mechanics and Hydraulics by Discharge, Chapter 5, Power and Efficiency. If the velocity of flow in a 90 mm diameter fire hose is 0.8 meters per second, what is the velocity in a 30 mm diameter jet issuing from a nozzle attached at the end of the pipe? Compute also the power available in the jet in watts. So first, we have here our given, the diameter of the hose that is equal to 0.09 meters. The velocity of fluid in the hose is equal to 0.8 meters per second, and the diameter in the jet that is equal to 0.03 meters. So here, we're gonna find the velocity of the fluid in the jet and the power it exerts. Here is the solution. We have this equation here. The fluid discharge in the hose is equal to the fluid discharge in the jet. So we expand this equation to this, that is the area times the velocity in the hose is equal to the area times the velocity in the jet. So area is equal to pi d squared over 4. So we have this final equation. The pi d squared over 4 times the velocity in the hose is equal to pi d squared over 4 times the velocity in the jet. To find the velocity of fluid in the jet, we have to plug in our values. So we have this pi times 0.09 meters squared over 4 times 0.8 meters per second is equal to pi times 0.3 meters per squared over 4 times the velocity of fluid in the jet. So here we have this answer, the 7.2 meters per second. And now we're gonna find the power that the jet exerts. So here we have this power is equal to the fluid discharge times the fluid discharge in the jet times the specific weight of the fluid times the energy, total energy. So here, the fluid discharge in the jet is equal to area times the velocity. So here we have this pi times 0.3 meters squared over 4 times 7.2 meters per second is equal to 0.005089 cubic meter per second. And now we're gonna find our total energy. So the total energy is equal to the kinetic energy since we don't have the potential energy. So the V squared over 2G is equal to 7.2 meters per second squared over 2 times 9.81 meters per second squared. That is equal to 2.6422 meters. So now we have the answer, and we plug in the values. So the power is equal to 0.005089 cubic meter per second times 9,810 Newton per cubic meter, that is the specific weight of the fluid, times 2.6422 meters. And now we have this final answer. We have the power that is equal to 131.907 watts. So that's the answer.